Welcome everyone to another video. Alright, so today we're going to be looking at half base times perpendicular height. For those who do not know, this is the area of a triangle, the formula so to speak. And over here we have a right triangle, meaning that this angle is 90 degrees. I'm just using this as the first example of what the formula means. So we're just going to look at the intuition behind this formula, and I'm going to go fairly fast because it's actually not that difficult. So over here, I wrote the half in red because that's where all the intuition is basically. So I'm going to just real quick scratch it out actually. Now, what are we left with? We're left with base times height. Now, I'm pretty sure this is ringing bells to somebody. Base times height, that is a square. Now, the base, they usually say for a square, length times length, or for a rectangle, length times breadth. So over here, we have length, and over here we have breadth. Now that is base times height. What can we do to make this a triangle? We can just draw a diagonal line and we have two equal triangles. Now, doesn't this look a little familiar? This is 90 degrees and so is this. So we're left with basically the same as this in the middle. Now, this is where all the intuition is, so I'm just going to use another colored pen. And I'm not going to use a ruler, so it's going to look a little unneat, but if you just draw from here outwards, you have another square. And this triangle is the same as this triangle. The length here is the same as the length here, and the length here is the same as the length here. So they're the same. If we were to calculate the area of the square, we would just say length times breadth. And here we have the same. We're just using base times height as a substitute, and that is because of a later example. So if we get the area of this, as you can see, this accounts for half of the area of the square, and this accounts for the other half, and that is because we are splitting it in half. Now, if we want to calculate the area of this one, since we know that this is half of the area of the square, why don't we just take the area of the square that it would make and divide it by 2, aka times it by a half, and we'll get the area of this one. That is the intuition behind the formula. Let's try with a different one, because instead of it being a square, it might end up being a parallelogram, or if it's equilateral, it might end up being a rhombus. So over here, let's draw a triangle that looks fairly equilateral. Don't know if you would call it equilateral though. And now we want to get the area of this one. It uses the same concept, except instead of getting a square or a rectangle, you'll now get a parallelogram, because as you can see, let me just see, where should I draw? Okay, we could draw it over here. Let me use another colored pen though. Over here. Now just imagine for a second that this has the same length and area as this one. We basically just created a parallelogram. Now, a parallelogram is the same as a rectangle because it's still calculated with base times height. And that is because if we just quickly make a little parallelogram, I'm sorry for the unneatness over here, but over here we have the base, and over here we have the height. Now, if we were to just cut this out, and we take this piece over here, and I'm gonna just quickly draw a little line over here to represent this one, so imagine that as being red. Now if we place that over here, we are left with, if you leave that piece out, another rectangle. And that is why a rhombus slash parallelogram can be calculated the same as a rectangle. That's just a little bonus thing you don't really need to know. But at the end of the day, you're calculating the area of the rhombus, the parallelogram, the rectangle, or the square that the triangle can make by adding another one. At the end of the day, you're just calculating what half of that is. And that is why there is a half over here. And you really can use it in many different ways. You can say half times base times height, or you can say half base times perpendicular height, or you can say half height times base. You could put that half anywhere, as long as if you say breadth times height and you get the answer, you can times that by half and you'll still get it, because all you're doing is getting the area of that square, rectangle, parallelogram, and then dividing it by half to get the triangle. So that is the intuition behind this formula, and I hope you guys enjoyed.